Good afternoon, my YouTube viewers. In this video, we're going to perform another nonparametric test. It's going to be the nonparametric Wilcoxon sign rank test. And so it's a little bit more complex than the previous sign test that we performed, but I'm going to go ahead and go through it to show you how to do it. So you've got subject is 1 to 6. You've got some values before treatment, and you've got some values after treatment. And then you've got the difference, and the difference is C2 minus B2 all the way down to C7. So you've got the difference between the after treatment and the before treatment. And then you've got the absolute value of the difference. So that's the absolute value of the difference. And then what you're going to do here is you're going to rank it. So rank.avg brackets E2, E2 to E7, 1. And then you copy that down all the way down to E7. And what that does is that ranks your value. And then so we assign a sign to the rank. So this is an if statement. If D2 is greater than 0, F2. If D2 is less than 0, negative F2. If D2 equals 0, and then it's just a blank. So we've got a bunch of negatives, and we've got one blank. So you have 5 non-zeros. So the number of positive ranks is 2.5. You're going to sum if G2 to G7 is greater than 0. You've got the number of negative ranks. So you've got the absolute value of sum if G2 to G7 is less than 0. And you've got the number of non-zero differences. So count if E2 to E7 is not equal to 0. So the test statistic is minimum of J2, which is 2.5, and J3, which is 17.5. So that's 2.5. And your alpha is 0.05, which is 5%, or your significance level. And then we have to calculate our critical value. And then so the critical value is norm.s.inv brackets 1 minus J9, that's 0.05 divided by 2. And it said that you use this only on large samples. And since we don't have a large sample, we have a small sample, then what we have to use is we have to use the table to the right. And basically, we only have 5 samples because one of the samples was a 0, so we use 0 as our critical Z value. So your null hypothesis is there's no significant difference between the paired data, and your alternate hypothesis is there is a significant difference between the paired data. So if J7 is greater than J11, that's your critical Z value. You're going to fail to reject the null hypothesis. Otherwise, you're going to reject the null hypothesis. So J7 is your test statistic, which is 2.5, and J11 is your critical Z value, which is 0. And since 2.5 is greater than J11, 0, then you're going to fail to reject the null hypothesis. And what I did was I created a chart with the Wilcoxon sign rank test, so you can see the values before and the values after, and you can see for yourself that there's not a significant difference between the values before and after. But you can always experiment with this and try to get it to reject the null hypothesis if you like. So that completes this video. The next video, we're going to be talking about another nonparametric test. So I hope you decide to watch it.